Hey there. Algebra. We are in lesson 24, only 2 more lessons to go before the end of the unit, and it's no joke. It's a tough unit, but you guys are doing fantastic. I'm telling you not to give up. So let's look at our silly riddle. Here is a riddle. I'm thinking of 2 numbers that add up to 5.678. And the difference between them is 9.876. What are the 2 numbers? All right, so let's name any pair of numbers whose sum is 5.678. I don't know. 2 plus 3.678. Name any pair of numbers whose difference is 9.876. 10 minus 0.04. I think that's right. Let me check. It is. Notice they're not the same pair. So this riddle can be represented with 2 equations. So write the equations. I know if I want any pair of numbers, x plus y is 5.678, and then difference x minus y equals 9.876. And then solve the riddle. Okay, explain or show your reasoning. I'm going to go ahead and add these 2 equations together because we've learned how to solve using elimination. Those cancel, and I'm left with 2x equals 5.678. I've got my rinky-dinky calculator here because I'm at home and I don't have my big calculator. 9.876. That gives me 15.554. And then divide both sides by 2. And I have x equals 7.777. And then I can go up here and do x plus y equals 5.678. But I can substitute instead of instead of x, oops, 7.777, subtract 7.777 from both sides, 5.678 minus, I have y equals negative 2.099. It's funny, I never dreamt of one of the numbers being negative. All right, now if I add those together, I get 5.678, and if I subtract them, I get 9.876. Crazy, I know. But it's a fun, silly riddle, and you see these in our curriculum a bit. At least I've seen them. All right, so to make a quilter is buying fabric in 2 colors, light and dark. Okay, let's talk about that for a second. Those aren't colors. Okay, colors are red, orange, yellow, green, blue, purple. I mean, we can even come up with funky colors, but light and dark are not 2 colors. Okay, I've said it. Let's move on. He needs at least 9.5 yards of fabric in total. So keep on reading. The light color costs $9 a yard. The dark color costs $13 a yard. The quilter can spend up to $110 on fabric. Here are 2 graphs that represent the 2 constraints. Pause. You guys know how to write 2 equations for this. Whenever we have 2 equations, we've got a system of equations. One of them is going to deal with counting things and adding them together, and the other one is going to deal with money. So I can say that light plus dark is at least 9.5. So it can be greater than or equal to 9.5. And then $9 for the light plus $13 for the dark can spend up to $110. That has to be less than or equal to $110. All right, so we have a system of equations here. Now let's turn the page. So here is the dark fabric, light fabric. I'm not sure what these two graphs that represent the two constraints. I would think that one of them is money and one of them is yardage. So I think this one might be our money one, and this one is the amount of yards. Let's see where we're going. Write an inequality to represent the length constraint. Let X represent yards of light fabric and Y represent yards of dark fabric. All right, I've already done this because I kind of get ahead of myself sometimes, don't I? Pause. There we are. So we know that inequality will represent length. I have X plus Y is greater than or equal to 9.5. Okay, that is what we're doing. Select all the pairs that satisfy the length constraint. So we're adding things together. It has to be greater than 9.5. My pen's still writing. There we go. 2.5 and 4.5, that's 5, 6, 7. 7.5 and 3.5, 8, 9, 10, 11, and 12 and 10. Okay, we've got them. And then write an inequality to represent the cost constraint. $9 for the light plus $13 for the dark has to be less than or equal to 110. Select all the pairs that satisfy the cost constraint. So 1 would be 9 plus 13 is less than 110. 4 times 9 is 36. That's a 6. Oops. 5 times 13 is 65. 65 plus 36 is 101. 8 times 9 is 72, plus 3 times 13, 111. Missed it by $1. And then 10 and 1 would be 90 plus 13 is 103. Yes. So we see which ones work. Those all satisfy the constraint. Explain why 2, satisfies the cost constraint but not the length constraint. So the cost constraint is 9 times 2 plus 13 times 2. This would be 18 plus 26. $44 is less than or equal to 110, but 2 plus 2 is not greater than or equal to 9.5. Okay, hold on. There was an alarm going off. Find at least one pair of numbers that satisfies both constraints. Be prepared to explain how you know. So let's just test one. Let's do 10 and 1. So I have 10 plus 1 is greater than 9.5, so it satisfies the yardage, the length constraint. And let's do the other one. So we did that one right here, and it was 103. Okay, so 10 and 1 does satisfy both, because 10 plus 1 is greater than or equal to 9.5, and 9 times 10 plus 13 times 1 is less than or equal to 110. Okay. What does the pair of numbers represent in this situation? It represents one possible solution to the system. Um, 10 yards, oops, of dark. Oh, which one's X? I can't remember. Light. 10 yards of light fabric and 1 yard of dark fabric satisfies the yardage and the budget. Okay, satisfies both. Good job. What we would do though, what I need you to understand is if I put both of these graphs on top of each other, the real solution is where they overlap. And I'm actually going to show you that. I don't like how the book doesn't tie that up in a nice, neat bow. So hold please. Graphing calculator. It's just going to be easier to see in Desmos. So as soon as this finishes loading, I'm going to say x plus y is greater than or equal to 9.5. And we're only going to be in quadrant 1 for this because it only makes sense if our x and our y variables are only positive. We are not going to have a negative x or y variable. So the only place we're going to find solutions that work is in this doubly shaded area. All right, that's where we find 10 and 1. See, it's right there. What other ones were possibilities? 8 and 2. It's right there in the doubly shaded area. And 6.5 and 3.5. Okay, right there. All three of those are in that shaded area. So those are possible solutions to our system. They make both equations true. Both inequalities, sorry, wrong word. They make both inequalities true. Okay, so they actually work. Do you hear my family? They're lovely. They're lovely. All right, so let's look at these situations. Here are some situations you've seen before. Answer the questions for one situation. Do you want to talk about bank accounts, concert tickets, or advertising packages? Let's talk concert tickets. I like going to concerts. 2 kinds of tickets to an outdoor concert were sold: lawn tickets and seat tickets. Fewer than 400 tickets in total were sold. Lawn tickets cost $30 each and seat tickets cost $50 each. Organizers want to make at least $14,000 from ticket sales. Okay, so that's our information. I know that lawn plus seat, fewer than 400. That's a dashed line. And then $30 for lawn plus $50 for seats, at least 14,000. That's a solid line. All right, so that is our system of equations. Right, a system of inequalities, it's a system of inequalities. When they're greater than or less than, they're called inequalities. I keep saying equations. It's not an equation because it's not an equal sign. Okay, so our concert tickets, our system of inequalities, I already wrote them because I can tend to do that sometimes. I have lawn seats plus seats have to be less than 400. And 30 for a lawn seat plus 50 for a seat have to be greater than or equal to 14,000. Okay? X equals number of lawn seats. Y equals number of seats. All right? Use technology to graph the inequalities and sketch the solution regions. Include labels and scales for the axis. I need you guys to practice doing this by hand. So I need to graph, I'll just do it up here, the X intercept and, oh gosh, sorry, the Y intercept and the X intercept. So for this one, I really usually just take my finger and cover over. So when 0 equals X, I just cover over the X like that. And I say, okay, Y equals 400. So 1, 2, 3, 400. And I put a dot there. Then I'll go and erase that, and the X disappears too. And then when I'm trying to find the X intercept, I plug in 0 for Y. So really, I just take my finger and I cover up the Y. And I say, okay, X is 400, and I'm not in red anymore. So 1, 200, 300, 400, and a dot. Now remember, this is just less than, so we don't draw a solid line because our solution is not on the line. It's just less than, not less than or equal to. So I want a dashed line in between these two. and it's less than, so I'm going to shade below. All right, let's switch to green. We're going to do the same thing, the y-intercept and the x-intercept. So I'm going to take my finger and cover up the x value, because that's 0. And I'm going to solve for, I don't know why I said that, that should be y. So divide both sides by 50. 14,000 divide by 50. 280. So y is, we'll just do this. 280. Okay, so now I'm going to erase. Sorry. I'm now going to plug in 0. 0 for y, which go here, and then divide both sides by 30. 14,000 divided by 30 is 466 2/3. So instead of x, we are at 466 2/3. And that's going to be, I haven't graphed yet. All right, we're in green, so our y-intercept is 280, 250, 60, 70, 80, about right there. Our y-intercept is 466, so this is going to be 500. That's going to be about right there, and we are a solid line, and we want our shading to be above. And what I need to be clear in is where our final solution is. It's where things overlap, which is right here. All right, let's see it for reals. All right, we have x plus y. Oh, y is less than 400. Lots of noises going on in the Shellhammer house today. Okay, there we go. And then 30x, what is it? 30x plus 50y is greater than or equal to 14,000. So our solution is going to be only in the first quadrant and only right up here. All right, that's our answer, which is what we did right there. It's where the green is. So the only solutions we have are the ones that are in that doubly shaded region. So right here, I can draw on this for a little bit, it doesn't stay. So all of the ordered pairs in this region, any ordered pair you find in here is our final solution. Okay, nothing on that dashed line. It can be on the solid line, but everything in there is a solution. I mean, right here, that is 50, 300. So 50, 300 is a solution. All right. This is 100, 250. And that means I could plug that ordered pair into both equations and I would get a true statement. All right. Let's see, where am I? Let's turn this off. Go back to our notes. All right. Okay, labels would be, I think this was lawn. Yep. Lawn seats and seats. And our scale, I mean, I didn't put in the zeros. Those are all hundreds. Okay, cool. Identify a solution to the system. What did I say? I found one. Let's look. This one is, let's see, 100. So 50, 300. This ordered pair right there should be a solution. Let's type it in. 50, 100. No, 300. Sorry. Yeah, so that should work. Let's go try it out. 50, 300. Notes. 50, 300. Okay, that means I can do 50 lawn seats and 300 seats. And I'll be within my constraints because 50 plus 300 is less than 400. And then what do we have? What's our other equation? 30x plus 50y should be greater than or equal to 14,000. Let's check it out. 50 times 30 is going to be 1,500. And this would be 50 times 30, 1,500, and then, oh, yeah, I was like, that's not going to work. $50 times 30 seats, or 300, is 15,000. That right there is greater than or equal to 14,000. $16,500 is greater than 14,000. So it works. Okay? Awesome. Love it when it does that. All right, so this lesson does have 4 parts. Members of a high school math club are doing a scavenger hunt. 3 items are hidden in the park, which is a rectangle that measures 50 meters by 20 meters. The clues are written as systems of equalities. One system has no solutions. The locations of the items can be narrowed down by solving the systems. A coordinate plane can be used to describe the solutions. Can you find the hidden items? Sketch a graph to show where each item could be hidden. All right, so clue number 1. Y is greater than 14. 10, 15. So this is Y is 14. It's dashed though. That's up here. We'll just do different colors. And then X is less than 10. Okay, so that's clue 1. X plus Y is less than 20. Let's do the X intercept and the Y intercept. So 0, comma, Y and X, comma, 0. So cover up the X value first, and I have Y is 20. Cover up the Y value, and I have X is 20. Dashed line. And we're less than, so we're going to graph underneath it. And then Y is greater than 6. Sorry, X is greater than 6. So that would be a dashed line right about here. And it goes this way. So they're doubly shaded here. We didn't do that. They're doubly shaded here. Okay. Clue 3. Here we have slope-intercept form. So let's go ahead and graph this first one. My y-intercept is 20, and my slope is -2, or -2 over 1. So I'm going to go down 2 squares and over 1 square. Down 2 squares over 1 square. And I'm a dashed line. And it's less than, so it's under the line. And then y is less than -2x plus 10. So here, our y-intercept is 10, and we're going down 2 over 1. So we're dashed line here. So we're doubly shaded just in this part. And this last one, the y-intercept of 10, a slope of 1, dashed line, oh, solid line, and we're greater than, which is all of this over here. I should get a highlighter out. And then X is greater than Y. But actually, let's change colors. That goes this way. Okay, dashed line. And we're greater than, so it's up here. All right, let's double check that there wasn't something I was supposed to be missing. Nope. Ooh, that last one I don't think I did right. Let's see. My y-intercept is 10. Solid line. And we're definitely greater than. Oh, I did my slope wrong. And I did it wrong again. Sorry, my slope is +1. So we're going this way. but we're a solid line. And we're greater than, so we're shading up here. And then this last one is x is greater than y. Dashed line goes this way, and it's actually y is less than x, so we're shading this way. So here we definitely have no solution because our graphs don't overlap. If your inequality graphs don't overlap, you have no solution. All right? Okay, we're not going to do that. But our lesson summary is very important, but that's in your curriculum. You can review it yourself. Good job.